All right, so this is the last piece of Unit 3, Part 1, going from standard form to vertex form using the AOS formula. AOS is your axis of symmetry. So using what we know about axis of symmetry and how it's related to vertex and how we can find axis of symmetry from the specific equation and going from there. So here we go. So let's recall. Standard form is when you have ax squared plus bx plus c, and standard form is going to give us our a value, which is our stretch or compression, our vertical stretch or compression, and if it also reflects. And then it also gives us our y-intercept. Our y-intercept is that c value. Vertex form gives us some good information too. Vertex is going to give us, obviously, our vertex, but it also gives us our a, and those a's are the same. The A from standard form is the same from vertex form. Those are the same values. They're going to do the same thing. It's going to tell you if it's stretching or compressing. It's going to tell you if it's reflecting. It's going to tell you all the exact same things because they're the same thing. So, but very important also to remember that the vertex goes through the axis of symmetry. We like to abbreviate things, call it AOS. Now, the axis of symmetry formula is opposite of b over 2a. I like to say opposite instead of negative because if my b value ends up being negative, I might get confused. So if I say opposite b, I'm always going to do the opposite of what it is. So if my b was negative, I'm going to go opposite and do positive, or if my b was positive, I'm going to do opposite and go negative. So axis of symmetry formula is going to give us our h of our vertex, because remember, it goes through the vertex. It gives us that x value of our vertex. So if we have our h, we're going to learn how we can then find our k and find our vertex form. So here are our 4 steps. Step 1, we're going to identify our a, b, and our c. When we're starting in standard form, we're going from standard form to vertex form. So we're first going to identify our a, b, and our c. Then we're going to use the AOS formula to find h. Okay, just showed you what the formula was. We're going to use it to find it. Then we're going to plug it into the standard form of the equation to find our k. Because your vertex is an x and a y. If I have my x, I can plug in and find my y. We just renamed them different letters. We renamed them h and k. Step 4 is we're going to write our new equation in vertex form, and don't forget the squared. 4 steps. So here is our first example, negative 2x squared minus 4x minus 1. I immediately start thinking about what my a, my b, and my c is. My a is the one in front of the x squared, my b is in front of the x, and my c is the one that's by itself. So my a is negative 2, my b is negative 4, and my c is negative 1. My a is the same. My a is negative 2, so I'm going to go ahead and write that I need my a, my h, and my k. And I already know my a is negative 2. Now, how do I find my h is by using the axis of symmetry formula. I'm going to do opposite of b over 2a. So opposite of b would be positive 4 because my b is negative 4. So I'm going to go opposite that. So opposite of b over 2a. 2 times my a, which in this case is negative 2. So doing some multiplication, 2 times negative 2 is negative 4. 4 over negative 4, my h is negative 1. So I'm going to go ahead and put that down here that I know my h is negative 1. Now, how do I find my k? Because now we're in step 3. Now I'm going to plug that back into my standard form equation. My standard form was the ax squared plus bx plus c. So I have negative 2 times negative 1 squared, plugging in negative 1 because that's my h into my x. The h is my x value of my vertex. So plugging in negative 1, minus 4 times negative 1, and then minus 1. Negative 1 squared is a positive 1. Negative 4 times negative 1 is a positive 4 minus 1. That is 2 plus 3. I just combined those last 2 at the end. And negative 2 plus 3 is 1. So that is my k. My k then is 1. So now I have my a, my h, and my k, and I can plug that into my vertex form. So my vertex form is y equals negative 2, x plus 1 squared plus 1. Now it is plus 1 inside because it is opposite h. We like to say opposite h instead of negative h as well. So it is opposite h, keep the k. So my h was negative 1, so I'm going to go opposite that and do plus 1. Keep your k. My k was positive 1, so it's plus 1. Next example, I have x squared plus 8x plus 19. So my a, my b, and my c. My a is 1, my b is 8, my c is 19. And I already know what my a is of my vertex form. My a is the same. If it was 1 there, it's going to be 1 here. I'm going to go opposite of b over 2a again. Opposite of b is a negative 8 this time over 2a, 2 times 1. So negative 8 divided by 2 is going to give me negative 4. So my h value is negative 4. Plug that into my standard form. So I have negative 4 squared. I'm inputting that I'm inputting that h, that is my x value of my vertex, and finding my y, which is my k. So plugging in negative 4, I get negative 4 squared plus 8 times negative 4 plus 19. Negative 4 squared is a positive 14. Negative times a negative is going to give you a positive. So positive 16 minus 32, because 8 times negative 4 is negative 32, and then plus 19. Using my calculator from there, I get that my y is equal to 3. So I have my a, my h, and my k, the 3 things I need for a vertex form. So my equation is y equals x plus 4 squared plus 3. I don't have an a, so I could easily put a 1 there if you want. You just don't need it, but we won't count it wrong. Opposite h, so I have plus 4 because my h there was a negative 4. So opposite h, keep your k. So plus 4 and then plus 3 in my equation. Okay, one that I want you to try, and then when you're ready, you can press play and the steps will go through. So the hard part about this one was you had a fraction, but a fraction, and a fraction as easy as 1/2, you could put in the calculator as a decimal, 0.5, and you could keep going with it. But that's really the kind of hardest part about this one. It ended up being fine. Your h ended up being 2 and your y ended up being 2. So in your equation you have 1/2 and then x minus 2 because it's opposite h. My h was positive, so in my equation it goes minus, and then plus 2 because you keep your k. All right. Another one I want for you to try. So on this one, your a was 2, your b was 12, and your c was 16. So opposite of b would give you a negative, which made your whole h be negative in this case. So your h was negative 3. When you plugged it back in, you just needed to be careful to say that negative 3 was going to give you a positive 9. And you found that your y was negative 2. So again, when you plug it into the equation, opposite h, keep the k. So plus 3 minus 2, and then your a from your original equation, your a from your standard form, becomes your a in your vertex form. All right, so now combining that with what we know about transformations and actually graphing these. So what do I know based on this? I know I can give my a, my b, and my c. I could put this into my notes. It's probably a good idea. So my a is 2, my b is 4, my c is 1. And right there I know that my y-intercept is 1. I also know that my a value in my vertex form is going to be 2. What I don't know is my vertex form, which was going to give me my transformations, and I don't know my axis of symmetry yet. So the next thing up is finding that axis of symmetry. So you do opposite of b over 2a, so 2 times 2. So that's negative 4 over 4, so my h is negative 1. If I know my h is negative 1, I now know that my axis of symmetry is negative 1. One less thing for me to find later. Plug it into standard form, because I don't have vertex form yet. Plug it into the standard form equation. I end up getting my k value. So that is 1 minus 4 plus 1. Positive 1, because negative 1 squared is positive. Negative 4, because 4 times negative 1 is going to give me negative. And that's going to give me negative 1. So I know that my k is negative 1. Putting that into vertex form. I have y equals 2 and then x plus 1, because it's opposite h. Keep your k. Based on that, I know my transformations. I know that I have a vertical stretch because my a is greater than 1. I'm going left 1 because I have a plus inside, and I'm going down 1 because I have a minus 1 outside. So now let's graph what I know. I know my y-intercept is 0, 1, and I know my vertex is at negative 1, negative 1. Now going back to what we did with transformation days, using your axis of symmetry as a reflection point. So that point right there, my y-intercept is 1 dot away from the center. so I go one dot in the other direction. There is my third point. All you need to graph are your 3 points. There is that parabola. It has a vertical stretch, it went left, and it went down. Those are my transformations. Now let's talk about domain and range. Domain on all parabolas, all quadratics, are going to be all real numbers. But my range, I'm going from low to high. So my range is from -1 to infinity. I have this one that I want you to try, so I want you to try it. When you're ready to see the answer and the whole work through, go ahead and press play. So hardest thing to catch on this one is that you have that negative out in front, and it's a -1, which is sometimes kind of hard to catch. So I don't think there were any, maybe there were, but I hope not, any issues with the equation, the opposite of b over 2a. You get that your h is equal to 1. It's the plugging in that could cause some issues. You have to keep that negative that's out in front. So you're going to do 1 squared, which is 1, but then you're going to multiply it back to by -1, which is going to give you a -1. So -1 plus 2 plus 1 is going to give you a +2. Again, you could use your calculator. So your k is 2. That means my vertex is 1, 2, which I graphed, over 1 up 2. My y-intercept was 1 based on my c value. My c value was 1. And then I use my axis of symmetry to reflect on the other side. You would normally connect these dots, okay? And when you connect these dots, you can see that it is reflected and that the whole thing got shifted right 1 and up 2 based on that maximum point. So my domain's still the same. Even if it's reflected left, right, up, down, doesn't matter. My domain's always going to be all real numbers. My range, though, because I'm going from low to high, I'm starting with my -infinity and I'm stopping at that 2. And the 2's included because it is a point, and so therefore it gets a bracket. So that is the last piece, going from standard form to vertex form and then tying all the things we know about vertex form and how to graph it. So graphing, essentially what we're doing is graphing from standard form, but we're having to convert it to vertex form in order to graph it. So that's it for Unit 3, Part 1.